Today, we will be learning how to multiply polynomials by lattice method.
The objectives are to learn to multiply polynomial expressions using lattice method, to apply lattice method in examples containing both integers and fractions conditions, and to learn the specifications of using lattice method.
First, get the degree of both factors, then add 1 to both the degrees. This is called the n plus 1 degree. Then make a table based on the n plus 1 degrees of both the factors. The columns correspond to the coefficients of the first factor, while the rows correspond to the coefficients of the second factor. Then proceed to draw a diagonal line in each cell. Multiply a column entry by a row entry and afterwards write the answer in the cell. Write zeros under each diagonal. Afterwards, get the sum of each diagonal. Continue doing this process until you have all the sums of all the diagonals. Once you have all of the sums of the diagonals, continue to formulate your final answer. The sums of these diagonals will correspond to the coefficients of the final answer. To get the exponents of your final answer, simply multiply the degree of the first and second factors, then write it together in decreasing order with your coefficients that you got with the sum of all the diagonals. Now we repeat the process again. Get the n plus 1 degree of both factors and then make a table out of it. This time, however, we have to add a 0 at the column since the first factor is missing an x. So now, we continue to make the table as taught in the previous example. We make the diagonals. Then we add the zeros under each diagonal. We then multiply the column entry by the row entry and write the answer in each cell. We get the sum of each diagonal and then we derive the final answer from it. And of course, you have to multiply the degrees of both factors and write it in decreasing order. And this is how the final answer will look like if you will still include the 0 that we equated earlier. However, the final answer will be the boxed one. On to the difficult level. You see, this particular example will be a bit more difficult because it involves a lot of fractions. So we make the table, and then we get the coefficients of the first factor and the second factor, and then put them on the table. We make the diagonals, and then we proceed to multiply the column entry by the row entry. So there it is, full of fractions. We get the sum of each diagonal, and then as usual, as taught in the previous examples, we derive the final answer. Now to summarize all of the things that we've discussed.